Say it again? Yes, absolutely. Thank you so much. So many things, right? I need to have into account, so therefore without your help I'll do something stupid. So that followed from equation 4, and that was x1 equals 0 and equation 4. So that's from perspective of skateboarder. That's how my axis look like, and that's in my perspective how skateboarders look like. In any case, you guys see that all this yellow section of the right side of yellow bar is in my future, because I'm in this segment's past. See, this is still in future comparing to that. So these light bulbs are in future comparing to that, and they are all simultaneous for skateboarder. So all these lights are turned on simultaneously for skateboarder, but later for me that will be in the future. Does this picture make sense? Yeah.
It should always be symmetric about the like a diagonal, right? Because
as we can see.
Yeah, because the Lorentz transformation matrix is also a symmetric matrix.
It looks symmetric this way, and graphically it means that slope with respect to x1 is the same as slope with respect to x naught. So this angle equals to this angle equals to that angle. Yep. Yep.
So, never mind.
Are you sure?
Yes.
Okay. All right.
Could you explain again just, so what criteria of the graph do look like in saying this is future and this is past?
If you take any point and you want to find on this point location, this will be location and time. This is time. So you could see that this event that happens at 0 time in bar frame of reference has positive time in unbarred frame of reference. Same as here. If you take exactly same point, and you could see that this is x. Let me call this event. This is x1 of event, and this is x naught of event. This is x1 of event, and this is x naught of event. Make sense? I wonder if I brought this book with me, and I don't think I have the name of the book in my notes. I might bring it next time. I will show you. I forgot the name of this guy. There is in Cambridge Publisher, they published a book about visual relativity. There are 0 equations, but lots of diagrams. You could answer lots of questions just by looking at these diagrams. If you took INT 84, you remember the name of that author from that class. If not, I'll bring it next time, or we'll just publish PDF of the that professor has a website at their university, and there is PDF of pre-books version, not exactly book, but pre-book version. You might find lots of interesting things that you can solve on the diagrams. All right, are we good? Okay. Now let's do something that has a lot of algebra, but will allow us to come up with the idea of momentum. First of all, what makes me say word momentum? If you remember in CS 32, we talked about uniformity of space and momentum, uniformity of time and energy. So apparently, if we understand that symmetry of space-time leads to conservation laws, then even if relativity is not fully built, but I believe that relativity is that major law of the relativity, like Newton's second law, is also differential equation of second order. If it is not differential equation of second order, then it will be a really, really interesting discovery, but more complicated than it appears to be. But if we believe that theory of relativity satisfies dynamic equation that is differential equation of second order, then there should exist Lagrangian. And if Lagrangian exists, then symmetry immediately tells that derivative of Lagrangian with respect to velocity is momentum, and it does
It's a constant.
exactly. It conserves over time total momentum of the system. Make sense? That should make us, because we built new theory. Who said that the word momentum exists there? That we can even apply notion of energy? Maybe not anymore. Maybe like lots of things from pre-relativistic theory about our intuition, about our understanding of world are gone. Maybe momentum is also gone, and energy. Apparently not. If you think that dynamic equation, no matter what it is, but if it exists, then there should be momentum. Interesting, right? So Noether's theorem actually sheds light on lots of expected things. We could expect that momentum exists. 5, 6. And I will start exploring vector momentum. Or I can start exploring px, py, which is vector momentum, right? In order to explore it, I could set actually a couple of Gedanken experiments that will narrow it down to one particular expression, which means that if momentum exists, it should be only that, or it doesn't exist. If it doesn't exist, then theory is more complicated than Lagrangian mechanics could explain. Did I deliver? So what I wanted you to catch from this passage, that it makes sense to think that momentum maybe exists. That's pretty safe from legal point of view statement. Nobody can sue me if momentum doesn't exist, because I made a safe statement. So if momentum exists, relativistic momentum, then I invite you to think about super lonely particle traveling with velocity u in absolutely empty space. It's such universe where nothing but one particle exists. Really boring world, right? Good. So if there is only one particle with velocity u, mass m, then what could momentum be of the universe? I don't know, maybe m squared u, or maybe mu squared divided by c, or I'm creative. Yes?
I have a question.
Yeah.
Because if there is only one particle in the universe, how would you define its velocity? Because velocity is like relative to other objects, right?
Yeah, but if I think mathematically, that's what theorists do, right? I could imagine xyz axis, t axis, and imagine that particle travels and covers distance. Even if experimentally, in order to measure, I need to put some devices. Yep, that's a cool question, but yeah, here is the answer. Alright, so what else we can say about momentum?
Function of m and u.
It could be a function of m and u, because those are the only two parameters that exist in the whole universe. So momentum is a function of m and u. But maybe I can make vector here. But if I don't want to put vector on f, what else I can do? Yes.
At low velocities, it should behave like Newtonian mechanics momentum.
This is a regular velocity dx dr dt.
You could put p hat or say that it's going to be parallel to u.
Because there's only one direction in the whole universe where particle travels. Imagining that if particle travels forward, but momentum is directed by 17.56223311 degrees, makes maybe sense, but not that much. So if you think that space is symmetric, beautiful, then direction of momentum could be u. I could either put here u hat, or say, you know what, if I put here u vector, this thing is still a function of m and u, right? It doesn't really matter. Does that make sense? honestly, I could imagine a weird thing, and if this will fail, then maybe next thing what I will try to do is that pi is equal to fij of mu times uj, which means that velocity is that way, momentum that way. Which actually happens to angular momentum and angular velocity. They are not parallel to each other because inertia is tensor. So for rotation, inertia is tensor. For regular motion, inertia is scalar called mass. Could I imagine a world with mass tensor? Sure. Then each of you will have mxx, mxy, mxz, etc. It means that I push you that way, you respond one way, I push you that way, you respond the other way. That would be really interesting, but thanks God it doesn't exist so far. Quick questions. We're good. All right, next statement. When velocity is much less than speed of light, then what do we expect?
MV.
We expect that momentum is mu, velocity of a particle, not a frame. What does this mean? It means that f of something is equal to m. Help.
M, 0.
Yep. It means that if velocity is approaching 0, then f should approach m. Does that make sense? All right? So hopefully it is interesting, right? Interesting observation.
Sorry, what is approaching 0? You mean
If velocity. So this is relativistic momentum. We assume that momentum could be not just mu. Direction-wise, we do not expect anything but the direction of u. But what u is multiplied by, we could expect any function of m and u because nothing else exists in the universe. You guys understand that theoretically nothing can be proved. Theoretically we can build something pretty. And then we need to go back to experimentalists and ask them, could you please check if what I made makes sense? Got it, right? All right, so here you go. Now I will make some kind of Gedanken experiment where I can predict the result because of it will be supersymmetric experiment. Question? All right. Is everybody good? All right. Imagine that I have two tennis balls. So this is one, or billiard balls, whatever, and this is the other. And imagine that this is number 1, and this one is number 2. And let's say I collided them so that tangency of the collision is in x direction. All right. So this is my x-axis. So then it will go that way, it will go that way, and I assume that both billiard balls or whatever it is, they both are have the exactly same mass. Does that make sense? All right. Let me also make sure that they travel with velocity where component in x is a, component in y is b. And second ball with exactly same mass originally travels with, let me use different color, I don't know why, but why not? Also travels with the same magnitudes but opposite directions in the velocities. If they are so symmetric and travel with so beautifully fit velocities, what do you expect for first ball final velocity? X component.
A.
Y component.
Minus B.
What about this? Negative A.
B.
Yeah. So we'll look at a beautifully symmetric case. Question?
Should that 2 in the bottom right be a 1?
Yep, absolutely. Thank you so much. Good. Yes. Any more keys? No? All right. Yay. Awesome. If you look at this collision from the frame of reference that travels with velocity a. So if this frame of reference is traveling with velocity a, then you could calculate new velocities of each particle. That I will do right now. Not bad exercise to do. I'll not do it. I'll later show you what will happen in that case. But not bad exercise for you to do is to look if momentum conserves. If you assume that momentum is just mu. For example, in this frame of reference, for sure, ma plus negative ma is 0. Same thing in y component, so 0 total momentum before collision, 0 total momentum after collision. Momentum conservation is there. But if you calculate these initial velocities and final velocities in this frame of reference, and will use momentum equal mu, you will find out that in that frame of reference, after relativistic transformation of velocities, you do not see any more conservation of momentum, which immediately proves that mu is not good equation. Makes perfect sense? I will not do that because what I will do covers this and all other cases. Because I will not say mu, I'll say f of mu times u, which includes also case m. If I cross out f and write big M, that will be this case. So therefore, what I will do is more general. So therefore, it is okay to do that. Now I will solve multiple problems about velocity transformation with your help. And I will just remind you that in bar frame of reference, what is ux bar?
ux
minus
minus
v.
Yep.
1 minus v over c squared
Ux a over c.
And I allowed myself to write a instead for v because moving frame is perfectly traveling with a velocity. Does that make perfect sense? If that does make perfect sense, then who can help me with u y bar? Yes, and gamma is
on the bottom.
so therefore this will be
uy.
uy.
Square root.
Square root of 1 minus a squared over c squared over the same denominator plus
You don't need to remember these equations. Honestly, I also don't remember, but I derive them as fast as I write, so it makes illusion that I really remember that, which is not true. All right, we're good? Awesome. So let me make here a column and 2 more. And hope we have enough room to do some craziness. All right, so this will be number 1. This will be number 2, which is number of the ball. And that will be information on velocity. So let me calculate velocity. I will not say number 1, I will just say x component of velocity in not bar frame of reference, initial, and then ax final. I don't remember if this is the best way to do it or initial final. Yeah, maybe this is, I forgot. One way the table looks better, the other way not as good. Who cares? So what is x component of ball 1 before collision? What about after collision? What about ball 2?
Minus minus.
What about uy initial, uy final, before and after? I mean, what I do right now is total stupidity. Let me still do it. First one,
B
b after,
minus B
second.
minus B. B.
Did everybody follow? Was it super duper clear? All right. So let me. All right. Now bad stuff. Question?
It's a question about a bit earlier, but
Yeah.
is there a reason, like, how do I put this? From the condition that at zero velocity, momentum should, like very small velocities, momentum should be nv, mu. Can dimensional analysis tell you that momentum should look like a dimensionless constant times mu?
You could do that, sure. I just know this way, I know how fast it brings me to the answer. I would suspect that your way it will be as fast. Yeah, it will be as fast. By the way, I recommend you doing it. It's like taking treadmill, slightly different color. Gray treadmill, now blue treadmill. It's really cool, it's less boring. Do that, if you wish. If you wish, forget about it. Definitely it will not be more complicated, you could do that. You guys heard that, right? Really cool thing, because that it will be mu. This will be dimensionless, first good thing. Second good thing, that dimensionless function approaches 1 at 0 velocity. Awesome. Absolutely beautiful idea. So let me go with ux bar initial.
0.
Yay! First one, a minus a. Amazing. What about second?
Still 0.
2a over
Negative a here. Minus a
minus
is,
2.
yep, minus 2a divided by
minus ux.
1
Oh, wait, 1 minus a squared over c squared.
plus,
Plus.
because ux is negative a, so negative a here makes it plus. Did everybody follow? Plus a squared over c squared. Is everybody good? Amazing. What about ux final bar?
0.
0.
Same thing as ux initial bar, and how about this guy? Same thing as initial bar, so I will not write exactly the same fraction once again. There's too much. Amazing. What about uy bar initial? Yeah. Life is tough. I agree.
Gamma.
I don't know gamma. I know this equation.
B times
Oh, b is good. 1 minus a squared over c squared. 1 minus a what? It's ux. Yep. A squared over c squared. I will not rush cancelling because there will be some substitutions. What about second one before collision?
Should it be 1 plus a squared over c squared?
Let's check it out. First one travels with velocity a. So ux is a, and so therefore minus.
Okay.
But for the second one, velocity is
Negative.
awesome. So not only numerator will be different, but denominator will be specifically different. Not just minus in front. Alright, so what is this?
Negative
Minus b squared.
1
minus b squared over c squared
Awesome.
over 1 plus a squared over c squared.
That's finally something less trivial. Usually it was more straightforward. I think I fit the whole table. So finally, uy final bar, first one.
Negative.
So first one has negative b times 1 minus a squared over c squared divided by,
1 minus.
see, that's unique, not same as this, not same as that. This guy,
B.
B square root of 1 minus a squared over c squared times over 1 plus a squared.
triple checking, things are looking okay. Yeah, and when I said unique, not completely minus of this. Yeah, whatever. I don't know why I need this uniqueness statement. Is everybody good? Did everybody follow me? So we transformed these velocities. That was the most boring thing ever, right? But it will help us to do something really cool. I want also, I don't want to write it, I will write it soon, but overall velocity that we substitute here in bar frame of reference will be, for instance, for first one before collision, it will be this square plus this square, right? This square plus this square. Does anybody want to do that? No, and things, I don't need it. So is all good? In a bar frame of reference, I will not write words, you can write words. In bar frame of reference, conservation of momentum looks like first f of, I do m first, okay, m, comma, u, initial of number 1. I don't know if I have any notation for this. Yes. U initial of number 1. What is U initial of number 1? Don't tell me what it is equal to. Describe it, what it is.
Magnitude of speed vector.
Magnitude of
Velocity.
initial velocity or speed of initial before collision. Is it super duper clear? What it is multiplied by? Oh, I didn't say that. I will write this for y bar only. I don't want for x. I could do that, but it will be useless. I already know answer. So, you know, maybe I told you multiple times that when something looks too fancy schmancy and you think, how could I come up with that? Don't worry, it doesn't mean that your instructor is so smart and you are so dumb. I just know the answer and you don't know the answer. That's what makes me look smarter than you. There is no other difference, all right? So I know that for x it will be useless, so I don't waste our time. I know for y it is useful, so I do this for y. Go. Number 1 multiplied by.
Uy I number 1.
If I do for y bar axis, then uy bar. What is it?
Inside f shouldn't ui number 1 should have a bar if it's for y bar.
That's absolutely important. Thank you so much. Because I do it for bar frame of reference. Everything should be from bar frame of reference. Awesome. Is it good? What about second ball? It will be f of same mass, but it will be u bar initial of number 2 multiplied by what?
Minus
Oh.
B.
Minus?
The same thing.
Oh,
No, because plus.
No.
yeah. B
Square
square root of over
1 plus a squared over b squared.
You guys see what happened? So this is expression. I mean, it's followable, right? You need to look in the frame, in the table, in the right places. What that is equal to? Help. It is equal to f m u final number 1 bar times what? Remember, we only do y-axis.
Negative b square root.
Okay, y final is this guy, so it will be negative b square root of 1 minus a squared over c squared divided by
1 minus a squared over c squared.
a squared over c squared. Continue. Next one is f m u bar final number 2 times
Positive
o
b square root 1
b
minus b square root 1 minus a squared over c squared on the bottom 1 plus a squared over c squared.
Amazing. Question. You guys see that this and this are same with the only correction minus here, right? What about u final and initial of the first ball?
The same.
Exactly. So if you look at an x component initial and y component initial and do Pythagorean calculation, then you take x component of
Should you be taking 0 as the x component?
initial.
That's not bar frame.
Yeah, that's what I'm
Yeah.
thinking about. I did something weird. In bar frame of reference, initial is, yep, someone said 0, now I put together two statements, you guys are right. This is initial, this square plus this square, and the final is same 0 square plus, this has minus sign, but when you square and add them together, you will get the same thing, right? Is it clear? So what does it mean? That this term and this term have exactly same absolute value, but with minus. What it means? We move exactly, if to the left side and put here 2. Do you guys see same thing happening here?
Yeah.
Double check. This square plus this square, I already see the circles. This square plus this square is equal to this square plus this square. Because this is just perfectly same and this is negative of that. That means that this and this term are by absolute value the same, they just have plus and minus sign. Now we can move this to the right side and it will be double that term. Is it super duper clear? So what it means? It means that this is equal to that. The rest I can erase. Did you follow me? Don't believe me, please. Don't think you are the dumbest person. If you don't see, immediately raise your hand. Don't think you are the dumbest person in the universe. Yes?
You get that side.
Sure! Do you see that this is same as that?
Yeah.
Do you see that this is same as that because same square plus square and equals same square plus square?
I don't understand why.
Speeds. Speed is x component square plus y component square under radical. This is same as that. I don't know why we did such a, this is 0. And this is same as that. Here I'm lazy.
Okay.
So this square plus this square is perfectly equal to this square plus this square. So speed before collision is equal to speed after collision.
Right.
That means that these two speeds are the same.
So f is a function for the speed.
F is a function of mass and speed.
Well,
And then explicitly multiplied by velocity to give, we separated direction and absolute value.
Okay.
Sounds good? Everybody is good? Awesome. If everybody is good, then next statement. Cancellations. Let me cancel. Do you guys see that radical is everywhere? What else is everywhere?
B.
So we got something absolutely beautiful because it looks simple. F of m comma u number 1, because initial final doesn't matter, right? multiplied by 1 over 1 minus a squared over c squared is equal to f of m u number 2 bar multiplied by 1 plus a squared over c squared. Is it clear after all cancellations? Is it super duper clear? It's not more complicated than algebra 1, but because too many terms, you need to be attentive. Question?
Since our functions are both proportional to m and m is the same in both, can we also just treat this as a function of just the velocity?
A function of which velocity?
Just the velocities and not mass. Because sides our function should
What if this is not linear dependence on mass? So, and I don't want to say what mass is. Maybe 1 kilogram, maybe 2. I want to see what it will look like.
okay.
Question?
Why does initial final not matter?
Because initial square equals to final square square. And same thing here, initial square equals final square plus, only because of that. Make sense?
Yeah.
Now, important transition. 6. Let me put new number. 7. I don't know why new number, but why not? I got this expression from physics of momentum conservation. Now I look at this as mathematically right expression, right? It should be always good. Let me forget, because now I cannot even interpret, after cancellation of something, I cannot interpret this from physics perspective. Some kind of mathematical relation between A's and U's, right? I can play with this expression wherever I want to, including after I already cancelled B. I can say, why not look at what happens to this expression at B equals 0? What happens if B is approaching 0? Make sense? If B is approaching 0, what happens to first one? This square plus this square. Ooh, 0. And what is f of m0? Ooh, beautiful. M 1 over 1 minus a squared over c squared equals. What happens to this? This square plus this square when b equals 0.
Just the first one squared.
Only this one squared. Awesome. So this is f of m, comma. Absolute value is 2a divided by 1 plus a squared over c squared. Multiplied by 1 plus a squared over c squared. So mathematically, problem is solved. F of m and 2a divided by 1 plus a squared over c squared is equal to old mass multiplied by 1 a squared over c squared, 1 a squared over c squared with minus. Is it clear? So if I call this xi or u, can I call it u? And we'll find how a depends on u, and we'll substitute here. Square in this couple of days calculations, I will get final answer, right? Is it clear? Do you guys see that mathematically problem is solved? I can call this u, solve this quadratic equation for a. That will be expression, substitute here, and we'll do some cancellations. I think once I tried it, it was more than 20 years ago, it was long. Now let me show you a quick, elegant way to do this. That was first written in Paul Bergman's book. Paul Bergman was Einstein's student. Einstein made preface to his book saying that's the best way to explain relativity. So many people still use some passages from Bergman's book because they're really creatively designed. So I won't call this u. And I want to explore f as a function of m and u. Oh, I have 3 minutes. That's enough. So something that should take a lot of time actually could be solved really quickly. All right, help. What if I want to write that expression this way? What should I do? Okay.
1 minus a squared over c.
May I write here radical?
Yes.
So what should I do immediately?
Multiply it by
Square.
Awesome.
Flip it over.
Can I write fraction equals 1 over fraction? Sure. What is it?
1
1 minus a squared
a squared over c squared over 2.
Isn't that equivalent to that?
Yeah.
Absolutely equivalent. Let me continue. I will write here m and here radical. What is that? This is 1 minus 2 a squared over c squared plus a to the 4 over c to the 4. Do you guys agree? And this has plus. In order to get here a plus, what should I add?
4. A squared over c squared.
And immediately?
Subtract 4.
Is it super duper clear? Yay?
Yes.
Everybody is good? Now you guys tell me, what is this?
Thing on the bottom.
Do you see that this is thing on the bottom? If you divide thing by itself, what you get? Exactly, you get 1. Awesome! And minus what?
4a.
Which is 2a divided by this, 1 plus a squared over c squared. What am I missing?
Square.
Square, 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 right? So squared. What else am I missing?
Over c squared.
Awesome. Is it equivalent? Huh? This is not c. This was supposed to be 1 plus, but I don't know why I put another parenthesis. Thanks.
That's u.
And what is 2a over 1 plus a squared over c squared?
U.
We call this u. And that is exactly the same expression. So what did we get? M divided by 1 minus u squared over c squared. That's f of mu. I have 40 seconds to write final answer. Final answer is that momentum is m with f, and f of m divided by 1 minus u squared over c squared multiplied by u. And this is relativistic momentum expression, which is also dl d gradient of u in of L in u space, right? Let me say pi is dl dui. That's precise expression. Make sense? So before Thursday, calculate what is Lagrangian, just integrating this in one-dimensional case. And for small velocities, it approaches to mu. For big velocities, we see what the deal. If you, for instance, do one-dimensional case, you see there is vertical asymptote on u equals c. So if you give particle momentum, you will increase momentum to infinity when you approach c. That's why nobody can exceed speed of light. You cannot increase momentum by infinity, exceed infinity, right? To move particle even faster. So that completes study of relativistic momentum. All right, let me close this session.